So that's very cool. And one of the reasons which makes it possible is that we have MMC card support now, so we can actually put the file system somewhere, which is really convenient. We have simple FB support. Simple FB is an interface between U-boot and the kernel, that the kernel knows which piece of memory is used for the frame buffer, but also which clocks are used for the frame buffer, so it shouldn't turn off those clocks. We had a huge flame fest on a number of upstream mailing lists to get the API between the kernel and U-boot fleshed out here. That took me a lot of blood, sweat, and tears, so to say. But it's there now, it's upstream, it's done, and it's working. And we even already have support for the latest SoC from Llwinner, the A80. But this is basic support. This is currently at the same level as where we were last FOSDEM for the A10, A13. So you get a UART basically, and you can boot from an SD card, from a memory image. So what's coming? Let me first tell you a little bit about how we bring up a new SoC for Sanxi. The Sanxi SoC itself has a little boot ROM inside, which is not capable of doing a lot. What it can do is it can load up to 24K of code from an SD card and copy that to its internal SRAM and execute it. So this is basically where we have a powerful SoC, but we're still talking microcontroller-ish stuff, right? We have 24K of code, that's it. In that 24K of code, we need to set up the DRAM controller. Well, first we need to program the power management IC. This is an external IC which creates all the voltages which are necessary on a board. We need to program that so that the DRAM actually gets power. Because if you don't give it any power, the DRAM won't work very well. Once the DRAM is powered up, we need to program the DRAM controller to actually talk to the DRAM and set all the timing parameters correctly for the DRAM used on the board. And then what happens is that there is also in the 24K a simple SD card driver which will load the real U-boot, which is about 400, 500K, so half a meg of code, to DRAM, and then we will jump into the real U-boot. So that's how basically a boot for U-boot works. We have a tiny first loader which is called the SPL, which stands for secondary payload, because the primary payload is the boot ROM which is wired inside the SoC. This is which starts executing. The secondary payload is the tiny loader which needs to initialize the powers and DRAM and then copy the real U-boot into DRAM and jump to DRAM. And then the actual U-boot runs, and the actual U-boot is therefore sometimes called the tertiary payload, which will load the Linux kernel, which is what we actually want. So that's the quaternary payload. So getting up a new SoC means that we need to build both an SPL and a U-boot binary. If you look at the custom bootloader, the proprietary bootloader which Llwinner ships, that also uses two stages. They call what we call the SPL boot 0. And then sometimes they have an extra thing called boot 1, and then they load U-boot. And on some versions they load U-boot directly from boot 0. So what we usually do is we start with just building only a U-boot binary, so we don't have to worry about power management, IC, DRAM init, etc. And then once we have the normal U-boot working using Llwinner's own boot 0, which is a proprietary blob basically to do the DRAM init, then we start working on our own SPL to replace the DRAM controller. So this means that the steps for getting up a new board are first of all just getting the basic U-boot going using Llwinner's own proprietary bootloader. And then once that works, we need to figure out how the clock tree setup and the power management IC and the DRAM controller actually works. This is nasty stuff, especially the DRAM controller, because there are no docs. Llwinner usually is working with us, they're giving us data sheets and whatever, but whatever IP block they are buying for their DRAM controller has some clause in the contract which they have with the IP vendor for that DRAM controller that they cannot tell us anything. They cannot give us code, they cannot give us data sheets, they give us nothing except boot 0. So to get the A23 up and running, as I said before, we now have A23 support full, so including SPL in U-boot. I basically had to disassemble boot 0 and look at every instruction what it was doing manually. A33 support is coming up. I was hoping it would be very similar to A23 since it's pin compatible, but they put in a different DRAM controller. So yesterday when I was in the train here, I spent 2 hours going through ARM disassembly again, figuring out how the DRAM init for A33 works. And I'm probably still going to spend 20, 30 more hours going to ARM disassembly, and then hopefully we will have DRAM in it for A33. So this gives you an idea where we are. At least for the A33, currently we are at me staring at disassembly listings. But there are more SOCs which we want to support. A80, the Llwinner A80, the octa-core, the big little one. Step 1 is complete, so we have a basic U-boot bin which we can load with Llwinner's boot 0. Step 2 is looking complicated because they are using 2 PMICs who are chained together. So they don't have one IC which creates all the voltages on the board, they have 2. And they're chained together somehow. And we don't have schematics of the board, so we don't know which voltage of the PMIC is going where, and we have about 16 PMIC voltages which we need to configure. But we don't know which one is going where or what it's powering. So this is still a bit of head scratching, and I've parked this for now, and I'm looking at the A33 because that looks to be lower hanging fruit at the moment. Then there also is something which is called the A83, which is the budget version of the A80. I know you can buy tablets with this SOC in there. That's what I know of this SoC. I know the marketing speak. I know there are tablets which I can buy, which I haven't done yet. So that gives you an idea of where the A83 support is. It's basically non-existent at the moment. The kernel roadmap. Real soon now, we have a contributor called Chen Yu who does lots of really great work. He's over there. Who does lots of great work for Llwinner support. And real soon now, we should, in the upstream kernel, have CPU frequency scaling support. So currently what happens is we ramp up the SoC CPU core voltage in U-boot to the maximum voltage. We ramp up the clock speed to the maximum clock speed, and that's what it's running at. That's what we're supporting. So this is running nice and hot. It's nice and warm. We should have CPU frequency scaling support soon. We should soon have A80 USB and MMC/SD card support, again thanks to Chen Yu. We have someone working on a DMA controller driver and on audio codec support. Those two go hand in hand. So we should soon be able to do audio output, at least over the analog outputs which a lot of boards have. I think we still need to figure out how to route that into HDMI. We know that the chip can do audio over HDMI, and that is what you want if you don't have any headphone connector like this thing. We know it's there. Once we have the basic audio codec support, it should be just a matter of gluing the two together. Famous last words. So that's something to, well, actually that's not something which we can do until we have a kernel mode setting driver for video, right? Because we need to integrate that at the kernel level. So work in progress is NAND support. NAND support is a problem because all the Llwinner devices use roll NAND. It's not like an SSD where there's a fancy controller which does a flash translation layer. It's roll NAND. You need to do everything yourself. The Linux kernel has a subsystem for this called the MTD, the Memory Technology Devices subsystem. And that is basically from the 80s. It's not really from the 80s. We didn't have Linux in the 80s yet, but it's old. It's meant for single level SLC, single level flash chips. Nowadays, everything is multi-level. It doesn't support that yet. We need support at the flash translation layer in the kernel for MLC devices. We have some patches for those, but no one is maintaining it, so no one is able to review those patches. So if you know anyone who's interested in doing MTD stuff in Linux, we could use help for the NAND support. Someone, don't remember his name, I must admit, has posted a patch head a while back for support for the hardware crypto engine, so you can do things like DES and AES in hardware on the SoC. I put those up as WIP, but they seem to currently be a bit stagnant. I hope someone will pick up that patch set again, or the original contributor will start working on it again soon. The last thing which is being worked on, which should be ready soon, is a driver for the AXP221 PMIC. The AXP chips from Llwinner are the power management ICs, so the one which make all the voltages and which you can use to configure, for example, the CPU core voltage. And we want that because if we can configure the CPU core voltage, then we can do frequency scaling and voltage scaling, matching that. So once we have that merged, we can probably also look forward to CPU frequency scaling for the A23. And who knows, maybe it will be the same for the A33. Planned, as in someone will start working on this soon, is a USB OTG support. This is a very important one. I said before we have OTG support in U-boot, which means that I can take a cheap tablet and then plug in a USB keyboard and interact with U-boot. And then I can tell U-boot to boot the kernel, and then I no longer have a working USB keyboard, because the kernel doesn't support OTG yet. So once we have this one, so I will start working on this real soon. And it looks pretty doable. I also did the U-boot patches, so I know what I'm talking about. Then you should be able to sort of use a tablet with a USB keyboard with stock Linux. And we also want to have a kernel mode setting driver, so we don't need to, can not only just take over the frame buffer setup by U-boot, but do smarter stuff like change resolutions or dynamically detect something is plugged in and react to that, etc. And Boris Brazilian, I hope I'm pronouncing his name correct, probably not, will hopefully soon start working on that, or he may already be working on that. And that leaves us with exactly 5 minutes for question.
We had MLC NAND working like 6 years ago, so if it's not in the kernel, something went wrong.
Sorry. Yeah, so let me repeat the question. The remark was we had MLC NANDs working something like 6 years ago, so if it's not in the kernel, something is wrong. You need to talk to Boris Brazilian about that, because he's doing the net stuff. I don't know the details. Something with randomizer support and hardware ECC, and we need support for those features and something like that.
Are you getting any support from Llwinner at all?
Yes, we are getting support in the form of, we can ask them questions, which they may or may not answer. Basically, they answer almost every question except when we have questions about the DRAM controller. We have full documentation except for the DRAM controller and the GPU, of course. But so in general, Llwinner is supportive. It is as supportive as they can be, giving their contracts with the IP vendors which they deal with, from whom they buy the IP which they use in their SoC. So, but yes, we have support from Llwinner. They help us. We can ask them questions and usually get answers and things like that. Yes?
Isn't part of the problem that they're sort of violating GPL in a number of places? Because otherwise the information would already be in their kernel sources.
There is a lot of info which we can get from their kernel sources. Yes, they do have something which could be considered GPL violations depending on your interpretation of the GPL, because they ship some object files instead of shipping source for every module which they ship. That's something up for debate. I mean, NVIDIA is doing the same for their binary blob driver for x86 GPUs, so that's debatable. I don't want to really go there because Llwinner is cooperating with us, and I don't want to tell them, yeah, but you are doing stuff which we don't like. Some people do yell very loudly that Llwinner is violating the GPL. I think that within the SoC world, they are one of the better vendors. Not the best, but one of the better. So for most of the stuff, the problem is not that we don't have the code. It's just that the Llwinner code is so horrible that it usually is better to just completely start from scratch than reusing their code. Or at least you need to do a lot of cleanup.
Except for the RAM controller.
Except for?
The DRAM controller.
The DRAM controller, we have no code, yes. But that's not part of the kernel, that's part of the bootloader. So they are not violating the GPL there. Yeah. Still, it was not really in the kernel. It was firmware which they were loading in another device, but doesn't matter much. Are there more questions? Yes?
What's the graphics driver situation?
What's the graphics driver situation? Luke, what's the graphics driver situation? No, Luke? Too bad. The problem is that there are 2 GPUs used. If I go back to the initial screen, you will see that there are 2 GPUs used. Hello? Yes, there we were. The Mali 400 has been reverse engineered, and Luc Verhagen has a Mesa driver for it, but he wants to not publish it until it's 110% ready. And code is never 110% ready, so please ask Luke if he will be so kind to publish his code so others could maybe integrate it further. Then the other part of it is that some of the newer ones have PowerVR graphics, and PowerVR graphics are basically never going to happen. It can be really simple there, they are never going to get supported in Linux. Unless PowerVR itself changes its mind and starting doing an open driver itself. So the GPU situation is Mali 400 is possible, but either we need someone to redo Luke's work. I think he did publish his Lima work, so the initial instruction set reverse engineering is public. So you could start implementing a Mesa driver based on that work, so then you have a lot of work to base on. Or someone needs to convince Luke to actually release his source and or integrate it with the existing upstream code, etc. Are there more questions? Okay. Oh, yes? All the way in the back. Can you scream or can someone bring you a mic? Wouldn't it be better to get Llwinner to do all this work themselves? Yes, definitely. If only they would hire competent engineers. Let me summarize it with that, pretty much. And it's, they are going for time to market, they are going for Android kernel, specific kernel patches and things like that, so they're not really interested in upstream kernel support, basically. That's the bottom line. Thanks for your time, everyone.